Hi, let's start with compliance and surfactants today. So, looking at the questions, you can see that one is talking about where the surfactant is produced from, and then what are the constituents of it. So, this is the basic concept that we need to understand. What is a surfactant? What kind of structure is it? Where is it produced from? All these questions need to be answered. Okay, so you can take a look over here. This is a flattened cell that you see over here. That is a type 1 cell, and over here you can see the type 2 cell. Okay, so we have the type 1 cell and type 2 cell, and this type 2 cell is where your surfactant is synthesized. Okay, so from the rough endoplasmic reticulum, Golgi apparatus, it becomes a composite body and then goes into forming the lamellar body, and finally tubular membranous secreta. So this order again can come as a question. And after that you can see the air fluid interface over here where the surfactants are there. So out of the constituents, what you have to understand is this dipalmitoyl phosphatidylcholine is a major constituent. More than 60% of your surfactant is that. Okay, so sometimes in the MCQ answers, they might give dipalmitoyl phosphatidyllecithin in the option. So if you don't know that it's the same thing, then you might not be able to answer the question. So remember that. Okay, so dipalmitoyl phosphatidylcholine or lecithin, whatever it's given, that is the answer. And also remember that this has amphiphilic structure similar to that we had seen in your membrane and all that. Okay, so this is a phospholipid sort of a thing. Okay, next is the primary function of surfactant. So you can see over here when we look at the air fluid interface, the molecules that are there, they're all tethered together. Okay, because of the intermolecular forces that are there, you see in every plane there's some sort of interaction. Okay, so this one molecule over here is pulled in this direction, this, and this, and this. Okay, so there's no net pull any side, but the ones that are there at the interface, what you'll notice is, although in all these directions they are there, there's no molecule which is over here that pulls in the same way. Okay, so in the air and water, the difference comes over there at the interface. So because of that, net pull is sort of going to be inside. So consider that, there's a bulk fluid and part of it goes like this, then that will sort of result in opposing forces developing here. So that is your surface tension that develops. Okay, so this is the surface tension that develops. Now, if you put your phospholipid structure, that is your surfactant, you'll understand that it's no longer going to be as high as before. That vector that you had seen, which is pulling it inside, it will kind of reduce and ultimately reduce the surface tension, because this molecule has a hydrophilic part which is attached to the water part and a hydrophobic part which is outside in the air. So even if there's a pull here, this tries to pull it inside, the hydrophobic part is not going to come inside the water. So because of that, resultant vector is kind of minimal. Okay, and that kind of reduces what you had seen earlier. So ultimately, what does the surfactant do in this fashion? It kind of reduces the surface tension. Okay. Now, apart from your phospholipid structure that we had seen, we have apoproteins also along with it. Okay, so we have your surfactant molecule which has your phospholipid. Along with that, it has your apoprotein. So major part is your phospholipid. Apart from that, there are certain other components which are there, and along with that we have apoproteins. Apoprotein by itself has different functions. So the most probable question that's going to come is innate immunity. So for innate immunity, SPA and SPD are known to be important. So just remember that SPA and SPD are for innate immunity. And we have SPB and C, which helps in the monomolecular layer formation and all that. Okay, so this is not that important. This is the most probable one that is going to come as a question. Okay. Okay, so another thing that you have to understand is another set of questions that is going to come, that is about the factors that increase and decrease the surfactants that are there. So thyroid hormone and glucocorticoids are factors that increase your surfactant. Cigarette is something that decreases surfactant. So this is just what has been asked for questions. So since this is asked, maybe in coming years they might put a different option and try to confuse you. So we'll just go ahead and try to understand what are the other factors which are there. So apart from cigarette, cutting both the vagi, occlusion of the pulmonary artery, or occlusion of main bronchus, and also long-term inhalation of 100% oxygen. So these are all factors that decrease the surfactant. And the factor that increases thyroid hormone and glucocorticoid. And of course, glucocorticoids, you must be knowing that. Okay, so that is why when there's a preterm delivery and all that, just before that, we kind of give the mother a shot of corticoids, and that to help the infant produce the surfactant that is needed. So next set of questions is about compliance. So what you can see here is how much is the compliance in the lung, and what does compliance actually mean. And we have a question here where different values are given and you have to calculate the compliance. Okay, so let's get to understanding what compliance is. So this one diagram, it's actually a plot between your pressure and the lung volume. So here you can see the transpulmonary pressure. So if you look at the transpulmonary pressure and the lung volume, the amount of change that is there in the volume for a unit change in your pressure, that is your compliance. So delta V by delta P. So for a unit change in your pressure, how much of change in volume is there? So diagrammatically you can observe it very well. If you take this unit from this point to this point, this one unit, you can see that the change in volume is from this till around here. Okay, this is the volume change that we see in this portion. Now if you take a look at this, the same thing, the same unit, okay, unit of this much, and you see that for that from here to here it has only increased this much. So you can see the difference in the compliance that is there. Okay, so that is the hysteresis that we see in your inflation curve. So this is inflation, this is deflation. Okay, so 2 points that are there, this is your normal slope that is there, but 2 points where it's kind of slowed down. Okay, so this point and this point. So this point, this slowing is because of the presence of surface tension. So when the volume is less and there's a air fluid interface, it kind of tends to make it collapse. So you'll have to need more force to actually open it up. Okay, so that is why at that point the compliance is low. And over here it is because of the elastic forces of lung. So lungs keeps expanding, ultimately at one point where the elastic forces of the lung to come back and recoil back to its original position take over. So at that point you can't inflate it more than what is there. So around 2/3 of it is the surface tension, 1/3 of it is the elastic forces of lung. Okay, so that is what is happening over here, and your normal value come to 0.2 liter. Please remember the liter per centimeter of water. So this is a normal value of your compliance of your lung. Okay, of your lung. Now let's come to the questions and the answer. The pulmonary surfactant secreted, so we know that it's from type 2 pneumocytes. Major surfactant is dipalmitoyl, phosphatidyl choline, or you can see lecithin. So this is the answer over here. Primary function of surfactant. So what it majorly does is it reduces the surface tension. Okay. So this also kind of prevents the airway closure, but not airway, alveoli actually. But this is basically the whole deal. True about the compliance of lung. So change in volume per unit change in pressure, that's true. The lung compliance is 0.2 liter per centimeter water, yes. Measure of distensibility, yes. So more compliant means more volume it can accommodate for a small change in pressure. So that means it's more distensible. Decrease in emphysema. So you know that in emphysema there's air trapping and all that. So in emphysema where there's air trapping, generally the compliance is much higher. Okay, so over there it's not decreased in compliance, it's actually increased. So the answer over here will be that. So just remember this because this I've seen in few questions. So this is the only one thing you have to remember. COPD, emphysema and all that. You have your increase in compliance. Compliance of lung. So this answer is 200 milliliter per centimeter of water. So as you remember, it is 0.2 liter. Okay, so 200 milliliter per centimeter of water. Patient inhales a tidal volume of 500 ml. Okay, and the interpleural pressure varied from -4 to -9. So what you have to understand is the change in pressure was -4 to -9. Okay, so that -4 to -9, that difference was able to bring about a volume of 500 ml. Okay, so this can be like, this. So -4 minus -9. Okay, but if you're looking at it as a transpulmonary pressure, transpulmonary pressure is actually your alveolar minus intrapleural. So intrapleural becomes a negative. So negative over negative, this ends up becoming positive, and the whole negative sign goes over there like that. So ultimately, whatever, all this you don't have to bother. Just 4, 9, what is the difference? 500. Okay. So the answer is going to be 0.1 liter per. So this is going to be 100 ml. So it's going to be 0.1 liter per centimeter. So that's going to be the answer for you.